Shreya, are you fine with that?
Yeah, I don't have a problem.
What time is your chemistry class?
So physics. Yeah, it's at morning from 8 to 10.
Okay.
Are you almost done with integration? Like your portion wise. It's almost over.
No, not yet. Can you see the screen now?
Yes, sir.
Okay. So today we had to start with application of integration, especially in geometry. Before that, if you have any type of doubt, questions, please do let me know.
Yeah, I do.
Yeah, tell me, sure, which question, which topic?
So 1 second. Integration only.
Okay.
So once I attempt the test thing, I'll send it to you and I'll ask you like any doubts that I have.
Okay.
So
Yes.
question number 75.
Question number 75 in the last assignment.
Indefinite integrals.
75 in indefinite integrals. Okay. Let me pick up the question. One by sine theta. 1 by 1 plus sine theta d theta, right?
Mm-hmm.
Okay.
D theta upon 1 plus.
Okay, so in this question, you first have to multiply and divide with 1 minus sine theta.
One minus sine theta by cos.
Okay, so it makes it 1 minus sine theta
By
cos square theta. And then individually divide 1 and sine theta by cos square theta. So it'll become secant square theta minus, the other term would become tan theta sec theta.
Sec square theta.
Okay. And in this case, integration of secant square would be tan of theta
minus sec theta.
Sec theta. Okay, plus c. This will be your answer. Next problem.
Okay. Question for 67.
Same worksheet?
Yeah.
Okay. Integration of e to the power 2x by 1 plus e to the power x. Now here, e to the power x you take as t. So e to the power x dx will be your dt. Okay. So here what you can do is, yeah, you can separate this e to the power x and e to the power x dx in the numerator. This part will start behaving as dt, right? So it will become t 1 plus t dt. Correct? Then you can do one thing, you can add and subtract a 1 from the numerator. So that would become 1 minus 1 by 1 plus t integral. That's going to be t minus ln of mod 1 plus t. Okay, plus c. Put back your t as e to the power x. This will be your answer.
So how do you know to add and subtract 1?
Yeah, that's a good question actually. See, basically you can do another thing. You can divide t by t plus 1. That's another thing that you can do. So you'll automatically put a 1 here. So it'll become t plus 1, right? And when you subtract, your remainder will be this. Correct? So you can, so when you divide it, you get a quotient of 1 and remainder
1
as
minus
this.
1.
Right? That will again lead to the same result what I got over here. This and this will become the same. But the idea is we do not know how to integrate something like a linear by linear. We can integrate constant by linear. So that's what the whole agenda of doing that. Even if I had a quadratic on top, I would have still divided it.
So you just want to get rid of a 1 by something.
So you can do partial fractions.
Of course, but this is already one factor. What will you do here? And
So
for
you
partial
just want to get rid
fractions,
of a 1 by something form. Right?
Yeah. And for partial fractions, you need to have the degree of the numerator smaller than the degree of the denominator. So the moment you do that, this is the term that you get, and you don't need a partial fraction here. It's oversimplified.
Right. Okay.
Okay.
Yeah.
Yeah. Next question.
Have to search. Give me 2 seconds.
Sure.
Okay, so there was this indefinite integrals. There was this question number 27.
Definite or indefinite?
Definite.
Question number 27, huh?
Yeah, I got the answer, but I just had a small doubt.
Question number 27 is using M3, find the approximate area of the shaded region below.
Correct. So I got the answer as 37. I did not know whether I should approximate it 36 or 38.
M3 means 3 parts, right?
Yeah. So you divide like 2, 4, 6.
Okay, let me just check it. So 1, 2, 3, 4, 5. So your function is given to you 6x minus x square from 0 to 6. So 2, 4, 6. Correct? Now from this midpoint, you put a M3, right?
Yeah.
Make a triangle like this. One, 3, 5.
Right.
Now at 1, the y value will be 5. Correct? So the first triangle, first rectangle, this would have an area of 2 into 5. Okay. Second rectangle, the height would be, when you put x as 3 in that, so it will be y is equal to 18 minus 9. That's going to be 9. So 9 into 2 would be the height. And for the third one, when you put a 5, you get 30. 30 minus 25.
Minus 25.
That's going to be 5. Okay, so it's 2 into 5. So it's 10, 18, and 10. That's going to be 38. Option D is correct.
Oh, I got the answer is 37, and then I approximated 38. Probably some calculation. Okay, never mind.
Great. Okay. Any other, Shreya?
No, sir. I think I'm done. I'm not all the calculator part of it.
Okay. And how did you attempt the objective test?
No, sir.
Aditya?
No, sir. That's what I said. Once I attempt it, I'll send you pictures, and then I'll ask you if I have it.
All right. Not an issue. Fine. So today we are going to look into application of integration to geometry. So this is your third last chapter. Application of integration to geometry. Acha, by the way, just before I forget this, since the vacations have started, we can have at least one hour of class every day, because from 29th to 11th I am not in town. Okay. So I think today being 14th, I guess, no, 13th. So we can have classes almost every day, one hour. Okay, so that we can easily complete our syllabus and do a bit of revision as well.
So we won't have class from 29th to 11th?
I would like to take it, but it would be through a mobile connection. So I don't know whether the network would be that great. Okay.
So you can give us papers to solve, or we can.
Of course, we'll finish the syllabus much before this. So we have 15 days, so we can have almost 30 hours of class if you want. Okay. So
Okay.
we'll have enough time. Don't worry. So, but I'm planning to take from Monday onwards at least 1.5 hours class every day for you.
Cool.
Okay.
Okay.
Fine.
Okay. So one more thing.
Yeah.
I asked you this before.
Yeah.
For logarithmic and exponential functions in relations and functions chapter, I wanted you to do a revision. I forgot. Can you do it after this is over?
Yeah, definitely. Okay, so first thing that we are going to apply our concept of integration, as we have already discussed, this area. Now, when I said area that time, and I also discussed with you, this expression actually signifies the area between the function and the x-axis. So basically, your x-axis is nothing but y is equal to 0, right? And this area is between two vertical lines, x equal to a till x equal to b. Correct?
Okay.
So I'm not saying this is exactly area. This helps us to find the area. Okay? Because again, sign has to be taken care of very, very carefully. So when you write this expression, it is akin to saying that you are writing this expression. Correct?
Yeah.
Now this signifies height of any thin rectangular strip that you make over here. Let's say I make this thin rectangular strip. The height will be the y coordinate of the top and the y coordinate of the bottom. The y coordinate of the top is this f of x. Y coordinate of the bottom of the strip is y equal to 0. So this difference signifies the height. So this is the height. Dx is basically your width of the strip. That is what this signifies. So this is your width of the strip. Correct? And hence this gives you the differential area of the strip, which we normally write it as dA. And when you integrate it from a to b, you end up finding this area value. Okay. And if you have chosen everything properly, that means your height and width both are positive. This will directly give you the area. You don't have to take any mod and all to make it as a positive quantity. Okay.
Yeah.
Now the same thing, if I generalize this and I say there are two curves and I want to find out the area sandwiched between them. Let's say I have a function like this. Okay. And I have another function like this. Okay. And I want to find out what is the area between these two curves. Let me name the curve as y is equal to f of x and the other one as y is equal to g of x. And I want to find out this area. Okay. The approach is very much similar as what I explained over here. I take a thin rectangular strip like this. What is the height of the strip? Height of the strip is the difference of the y coordinates at the head and the foot of the strip.
So f of x minus g of x.
G of x. Now, how would I know whether f of x is greater or g of x is greater? For that, you need to know their graphs very well. And hence, the function chapter was for you to know the graphs of these functions very well. Okay. So in order to know which is higher, which is lower, whether to do f of x minus g of x or whether to do g of x minus f of x, because in the question, they will just mention you the functions. So you need to know exactly how they appear on the graph relative to each other. And therefore, you will be able to figure out which has to be taken as the first function and which has to be taken as the second function, right? Which is the top minus bottom. Okay.
Yes.
And of course, you need to know their intersection point, if at all they are intersecting, or you need to know the values of a and b from where you have to integrate. And this will give you the area between those two curves.
So why do you need to know the intersection point?
Okay, let's say I give you a question like this. Let's say I ask you, what is the area sandwiched between the parabola y square is equal to 4ax, okay, and x square is equal to 4ay. Okay. For the sake of convenience, since I'm taking it as a first example, let me drop A and put 1 in place of that. So if I draw this, first of all, I should know what are the shapes of these two figures. So this will be a parabola.
One will be downward.
One will be like.
One will be like this.
Yeah, and one will be up.
Whose axis is your x-axis? Another will be up.
And up like that, yeah.
Correct?
Yeah.
So I want the area which is trapped between these two curves. That means I'm looking for this area. Right? Now, if I choose a differential strip like this, right? What is the f on the upper part of the curve?
Y square equal to 4.
Yeah, you can write it as root of 4x.
Root of 4x.
Now remember, in parabola also, the two branches represent two different curves. This is y is equal to root 4x. The down fellow is y is equal to
minus
negative
root 4x.
Root 4x, yes. Okay. And the down curve is what? The down curve is y is equal to root
X
of
is equal to root of 4 of y.
No, y is equal to x square by 4, correct? We need their y's. We need the difference of their y's.
Right, okay.
Correct. So it would be under root of 4x minus x square by 4. That will be the height. Correct? Thickness will be dx.
Yeah.
Correct? Now, for you to know whether you have to do root of 4x minus x square by 4 or x square minus 4 minus root 4x, you need to know their exact positions. Okay? Yeah.
Okay.
Hence, you should know how to plot them. Now, of course, if you have to integrate it, you'll integrate it from 0 to this point, let's say. Now, what is this point? In order to find this point, we have to simultaneously solve them. That means we have to see their intersection point. Right? Yes or no?
Yeah.
So, can you tell me how will I find them? What would be the intersection of these two?
X square by 4 equal to root of 4x.
Or you can do one thing. You can square this both sides. When you square this both sides, you'll get x to the power 4 as 16y square. And in place of y, you can put a 4x.
4x.
Correct? So one point definitely will be x equal to 0. So I'm just removing it, and at the same time I'm cancelling it. So x cube
will be 4.
So x will be 4. So this point is x equal to 4. Clear, Shreya? So this integration will happen from 0 to 4. Understood? So now you can evaluate it.
Yeah.
Do I need to do it?
No.
Okay. So now I'll give you some questions.
So we're not allowed to use calculator for this, no?
There are some questions where you will need a calculator. But remember, your some papers are without calculator, so you're not allowed to use calculator there. So these will be coming under those non-calculator questions.
Right. Okay.
Okay. Question is, find the area by the way, both of you have calculators ready with you?
No. I can get it.
Yeah, please get it, because you may need calculator somewhere.
Okay, cool.
Sir, I don't have mine now. I have to borrow it from my friend. Like I got,
okay.
I have a source, but I don't have it. But now I can use like test process.
Okay, fine, no problem. Give the area of the region whose boundaries are given by. Give the area of the region whose boundaries is given by x is equal to y square minus 1 and the y-axis.
Do you have to use calculator for this
one? No, not required. Not for this one. I'll tell you when to use the calculator.
Wait, so do we have to find like only the y coordinates, like in the previous one we only use the y coordinates, right?
Yeah, we have to find.
No, first make the diagram, will come to know. Find the area whose boundaries are given by these figures. So when the moment you draw it, you'll come to know what area they are looking for.
So it's like a U, but it never crosses. It never becomes negative. I mean the first one.
What about you? What's the answer coming up? Did you plot their graphs first?
Yes, sir.
Okay. Y square is equal to x plus 1. What would you do for that? First of all, what is the graph of
Okay.
y square is equal to x?
Y square to x is a para.
It's a
just
para.
parabola.
It's a para, right? Parabola like this.
Yeah. And then you shift it 1 unit.
If you do one, what happens? It goes 1
Shift
unit
it
back.
Back.
Okay, so do you realize it will be like this?
Yeah.
Correct?
Mm.
Let me erase the old one. Okay.
Mhm.
Now, see what they're asking. Between this graph and the y-axis. So automatically, you know, this is the area that they're looking for.
Right.
Correct?
Yeah.
Right? Now, see the problem here. The moment you make a vertical strip like this, the top part of the strip and the bottom part of the strip are on the same curves.
Mm-hmm.
So what will you do?
You take horizontal strips. And then
Okay, that's one of the ways. But I want to really ask you, is this part of the curve, that is the upper part and the lower part, do they have the same equations?
No.
no, one is y square is x and one is y square is minus
It's
x.
minus x.
So one is y square, y is equal to under root of x plus 1, and the other is y is
Y
equal
is
to
minus under root of x.
correct. So if I take the top minus bottom, won't it be under root of x plus 1 minus of minus under root x plus 1? Won't this be the height?
Yeah.
Correct. And if you integrate this from this point x equal to -1 till x equal to 0, shouldn't it give me the answer? That means indirectly I'm asking you to integrate this.
So, but it doesn't have a point. Like it doesn't have a point from the on the y-axis though, right? Like when you're taking your horizontal, when you're taking your vertical strip up, shouldn't it have a point lying on the y-axis? Because
I didn't get your concern.
it says that find the area of the region between the parabola and the y-axis.
Right.
So shouldn't your vertical strip include the y-axis? Like shouldn't it be somewhere lying on the y-axis as well?
No. This you didn't understand the concept then. Basically, this strip will go all the way from this point to this point.
Yeah, I know that.
So everything is covered. No, the moment you integrate it from -1 to 0, your strips will go from this end of the area to this end of the area.
Okay.
It'll sweep all the area.
Alright, yeah.
What was your concern? I didn't understand exactly when you said it should lie on the y-axis.
No, like I thought that it should like the vertical strip that you're taking should include like I don't know how to explain it. Anyway, I got it. Never mind.
This is just an exemplary strip.
Yeah.
You just choose anywhere in the area and you make a strip just to know that if I have to go from this point to this point, under which two curves I will be lying.
Yeah.
Okay.
Yeah.
So, Papa will come after the class. Go. Take it out. Yeah. So did you integrate it?
So doing.
Yeah. Is it taking so much time?
Just a sec.
I thought we just had to integrate x plus 1 to the power half.
What are you doing?
That's it. So it's going to be 4/3 of x plus 1 to the power of 3/2. And we have to integrate it from -1 to 0. When you put a 0, it gives you 4/3. And when you could put a -1, you'll actually get a 0. So your answer is going to be 4/3 square units. Why square units? Because you're dealing with area.
Yeah.
Got it?
Yeah.
Let's take another example.
Yeah.
Again, I'm repeating, you have to be very, very good with sketching the curves. That is the trick of this game. Find the area between the parabola. Same question. Find the area bounded, whose boundaries are these curves. That is y square is equal to x, and the line x plus y is equal to 2.
Mhm.
Done?
So will it
Hold on a
be
second.
uh,
Yeah, you can.
will it be 2 minus x minus root x integral?
I just have the options with me.
Okay. I have the graph.
Both are simple figures. One is a parabola, other is a straight line.
Correct. Upward opening parabola and
Yeah. Upward sloping
downward.
parabola.
No, it's a sideward opening.
No.
Yeah, it's a
Yeah.
sideward.
No, I'm talking about the straight line.
Oh, okay. There's no. Okay.
And this line is like this.
Exactly, yeah.
Yeah, that's what.
I have to extend this even further. Okay. Yeah, so we need this area, the area which is between these two curves.
Yeah. That's it.
Okay, let's look into this.
So it is a y quad. Okay.
See, I've drawn a red line. Okay. Why I've
Yeah.
drawn this line is because before the red line, the situation will be your strip will be starting from parabola, ending on parabola, right?
Yeah.
After the red line, your strip will be starting from line and ending on the parabola.
Right.
Do you realize that? So in this
Yeah.
zone, your strip will be starting from the parabola, ending on the parabola. And in this zone, your strip will be starting from the line and ending on the parabola. Okay? This can only be figured out if you know your graphs very well, right? It cannot be guessed. Okay? Now, for that I need to know this deciding point. What is the coordinate of this deciding point? Okay? So for that I need to know where is the line and the parabola meeting each other. So here I can say my y is equal to 2 minus x. Correct? From this line I can
Yes.
say. Substitute it in the parabola
Root
equation.
x is O.
Okay? You'll get a quadratic.
X square minus 4x plus
Yeah.
4 equal to.
X square minus 5x plus 4.
Correct? X square minus 5x plus 4 equal to 0.
So x minus 1 into
X minus 4
1
into X
into.
minus 1.
Right. So x will be 1 and x will be 4. Now why 2 points are coming? Is because they will meet at x equal to 1 also. And they will meet at x equal to 4 also. Understood? Correct. Now see. From 0 to 1. My strip will have its head on y equal to root x and its tail on y is equal to negative root x. So what is the difference between root x and negative root x?
2 root x.
2
2
root
root
x.
x. From 1 to 4, the head of the strip will be on 2 minus x. That is the y for the line.
Minus x minus root x.
Yes. Minus y for this, which will be plus root x.
Plus root x.
Plus root x. Yeah.
Now please integrate this and tell me the result that you get.
So 6x to the power 3 by 2 by 3 minus x square by 2 plus 2.
You get the answer.
Huh? So what did you say?
Give me the final result.
He wants it for the limits. So.
Oh, right. Oh, right.
The end result.
Yeah.
You can make your life simple by combining at least 0 to 1 and 1 to 4 of root x.
Mhm.
Yeah, that's it.
Okay, let me just perform this integration quickly. So this will be 2. Root x integration will be x to the power 3 by 2
3 by 2 by 3.
divided by 3 by 2.
So that's 4 into it.
Okay.
Says answer 19 by 2.
19 by 2 is not in the options. Okay. Let's look into this part. 2x minus x square by 2. And again x to the power 3 by 2 divided by 3 by 2 from 4 to 1. Okay. So this will be 4 by 3. 4 by 3. X to the power x is 1. So that will be 4 by 3 only. This will be, when you put a 4, you get a 8. And you get a 16 minus 4. That's again an 8. And 2/3 of 8. And when you put a 1, you get a 2 minus half plus 2 by 3. So that will be 4 by 3 plus, this will go off, this will be 16 by 3 minus, this will be 3 by 2 plus 2 by 3. Cool? So far it's good?
Yeah, so
Yeah.
So it's 4 by 3 plus this will be 20 by 3.
19 by 3.
20 by 3. And this minus part would be 9 plus 4, 13 by 6. Okay. So basically, your answer will be 40 minus 13 by 6. That's 27 by 6 if I'm not wrong. And you can cancel off by a factor of 3. That's 9 by 2. 9 by 2 is, yes, that is there in the option and that is correct. Is that fine, Shreya and Aditya?
Yes, sir.
Okay, try one more.
Okay.
Because this is there in your CBSE board as well. You have to do it sooner or later. Find the area enclosed between the boundaries of the curve.
So I can't hear you really.
Yours is some disturbance.
Find the area enclosed between the boundaries of the curve. Y is equal to, just look at the curves. This curve, x-axis, and vertical lines, x equal to 2 and x equal to minus 2.
There are 4 lines.
There are 4 curves, yes.
So this week a new graph calculator.
They say answer these questions without using your calculator.
So it'll be like a sort of trapezium, like the area.
Okay. is for sure that this graph is symmetrical about the y-axis, right? How is it sure that it's symmetrical about the y-axis?
Because f of minus x is equal to it.
Of course, because the power of x present in the question is even. So it will be symmetrical about y-axis. Correct?
Yeah.
Now, as you can also see that when x is 0, it will have a max value of 1. And the moment you increase the value of x, it starts falling down.
Yeah, it's a downward slope.
And it will never touch the x-axis, by the way, because for it
It's
to happen,
asymptotic.
yes, for it to happen, you need a very infinite value of x. So in light of all these things, when you sketch the graph, correct me if I'm wrong, it will be a curve which is falling like this.
Yeah.
Okay.
Yeah.
Now, how do I know it's falling like this and not falling like this? Why did I make a roundish kind of thing over here? According to me, the curve should be like this.
Because it's concave down.
Why not like this? Since you have now learned your differentiability.
Sir, I can't hear you.
It has concave down.
Yeah.
Shreya?
So I'm thinking,
What, you take the double derivative and see what?
Now, if this was the case, that is the lower curve was the case, it would not have been differentiable at 0.
but it is differential.
But it is differentiable because I can easily differentiate it at 0 because the value of it can be obtained by putting x as 0. Okay. So there has to be a slope of 0 at 0.
Wait, so why wouldn't it be differentiable at 0? Oh, because it's like
Because
cusp.
the
It's a cusp.
Cusp getting formed. Exactly. Okay. So in light of this, we conclude that
should be down here.
my curve is going to be looking like this. Correct? Exactly symmetrical. Okay. Now x equal to minus 2 and x equal to 2 would be this area. And I need a graph between the curve and the x-axis. That means they want this area to be found out. Okay. So once you know these positions, you will be able to figure out. Now I can see that from the symmetry of the figure, if I integrate the area between 0 to 2 and twice it up, I should get my answer.
Yeah.
Yeah.
But what should I integrate?
From
Again, draw a strip, you will come to know that from where to where, what minus what you have to do. So here, upper minus lower. So what is the y of the upper?
4 upon x minus 1.
What is the y of the lower?
0.
0.
So you have to integrate this. So that means you have to integrate 8 times 0 to 2, 1 by x square plus 4 dx.
That's 8 log x square plus.
Now this is a square, x square plus a square type of integration, correct? I don't know whether you remember the result. It's 1 by 8 tan inverse x by.
Oh, yes. Yes.
So it's 1 by 2 tan inverse x by 2. So it will be 4 times tan inverse of x by 2. Now the moment you put 2, you get tan inverse of 1, which is going to be pi by 4, and the other would be 0. So the answer will be pi square units.
Yes, sir.
What happened, Shreya? You're looking down.
No.
You are sounding quite down. Tired?
No, sir. No, probably because of the disturbance at the back. Yes.
Who's disturbance?
I don't know. Is
I'm
it
fine.
not yours? Whose is it?
It's not mine.
Oh.
No, it's not mine.
Oh, not. And whose is it? I don't know. There's someone's playing some instrument at the back.
Oh, yeah,
so that's Aditya.
that could be mine, I think. But it's not an instrument.
Bro, it's some kind of function. It's some festival going on in the back.
Yeah, but like it's like pretty far away. I don't know. Wait, so just could you go to the previous slide?
Yeah, sure.
So dx by 1 by x square plus a square derivative is 1 by a tan inverse.
Mhm.
Is that fine now?
Yeah.
Okay, next question is find the area between the parabolas x is equal to y square minus 5y and x is equal to 3y minus y square.
That's it.
Mhm. So here you can't do without calculator.
No, you don't need a calculator anyway.
That's weird.
Yeah.
Now it is prominent.
Huh?
Could you sketch the graphs?
Yeah. But they're like, I think they're opposite parabolas, like one facing right and one facing left.
Okay, so how to sketch them? Very simple. First, you complete the perfect square over here. Agreed?
So, yeah. Yeah.
Correct?
Yep.
Similarly for this,
Same thing.
okay? So this will be y minus 3 by 2 the whole square is negative of x minus 9 by 4. Okay? Now this belongs to this species.
So why do you decide to complete the square?
Because then I know the orientation of these parabolas. Y minus and x plus or x minus signifies the shifting of the vertex. Okay, let me show you how it works.
Mhm.
So if I plot this one, it's going to be having its vertex at minus 25 by 4 comma 5 by 2. So the vertex of this parabola is going to be at minus 25 by 4, comma 5 by 2. That's somewhere over here. Okay. And this signifies its opening rightwards. Correct? Okay. So this will open rightwards like this. But remember, it will pass through the origin.
Right. Yeah, it does.
Because you can see that there is no constant in the curve. So when you put x as 0, y will be 0. When you put y as 0, x will be 0. Okay. The other curve will also pass through origin only, but this time the vertex of this parabola would be at 3 by 2, comma 9 by 4.
So 9 by 4, comma 3 by 2.
Wow, sorry. Yeah. 9 by 4, comma 3 by 2. So this will be 9 by 4, comma 3 by 2. So 9 by 4, comma 3 by 2 would be like this. Okay. So which area they are looking for? They are looking for this area. Okay. Now can you find them?
So when you solve them, you get that the y coordinate.
So there'll be 3 separate regions there. One which is between one. There'll be 3 separate strips which you can get.
Okay. Now if you have 3 separate strips.
Aditya, can you use earphones? It's really becoming loud. I can't hear.
I'm using it.
Use it somewhere else. It's really loud.
I don't think it's from my place.
Yeah, it's from your place only.
I can't hear it.
I am using headphones. So.
Now it's a bit manageable.
Yeah, now it's better. That time it was.
Okay. Okay. Now,
So one meeting point, the y coordinate is 4.
Yeah, we'll work out that later on.
Yeah.
So here, for a change, I will like to take a horizontal strip. Now, what is the story behind finding the area with horizontal strip? It's not different. It's almost the same. It's just that now your curves would be treated as x equal to fy and x equal to gy curves. Okay? And then you have to take the right minus left, that is fy minus gy. And this thickness is going to be dy thickness. And this has to be integrated from this value of y till whatever value of y is here. From, let's say, A to B point. Understood this theory part?
So why did you take horizontal strip?
Yeah, because as you were telling that now I have to divide it into 4 regions, right?
Exactly.
So that would be too much. I mean, that would waste a lot of our time. And secondly, you would realize writing x and x for both the curves are easy because the curves themselves have been given in terms of x.
Right.
Okay.
Yeah.
Right. So horizontal strip, you don't have to see, okay, from here to here I have to use this, from here to here I have to use this minus this, and then from here to here I have to use this minus this. Else you'll have 3 zones. Let me draw it in a miniature version. Let's say if you have not used horizontal strips. I'm sorry. Oh my god, firing.
They're boasting some crackers. I think it's for Ram Navami or something.
It's really bad.
Aditya,
I can't
you should have
hear
told them, no, that there's a class going on.
It's not. How can I?
As if they care about it.
Yeah, it's not even. It's not even my apartment. There's some temple sort of place close by, and it's.
Ram Navami, bro.
I don't know why they
Acha,
have to burst crackers and waste everyone's night.
okay.
I remember last year I got really irritated.
Yeah, see here, if I take vertical strips,
Yeah,
then I
it's
have to
multiple.
manage a strip like this where you have upper curve as this parabola, lower curve also the same parabola, correct?
Yeah.
From this position of x, let's say x equal to a, to this position of x, let's say x equal to b. From in this zone, your strip will be from this parabola to this parabola, correct?
Mm-hmm.
Till C point.
Mm-hmm.
And from C to this point, let me call it D point, your strip will be starting from this parabola only and ending on the same parabola. Okay? So unnecessarily, you'll have to change the limits of integration thrice.
Yeah.
Here, you don't need to do that. Right? Here, you just have to do f of the upper rightmost curve. Sorry, x of the rightmost curve. What is this rightmost curve?
Y square is equal to x plus 5y.
What is this guy?
Y square is x plus 5y. So x plus root x plus 5y.
Root x is 5.
It's going to be y square minus 5y, correct? Correct?
Oh, okay. Yeah,
Minus-
that too. Yeah, that too.
Minus
Minus
the left curve.
3y
3y
minus y square.
So,
Once
but why
again,
is
once
it in
again.
terms of
It's
x?
the other way around, guys. Other way around. Right curve is the one which is opening leftwards. So it has to be 3y minus y square.
So, but why is it in terms of x?
Because he just said you can't
Wait.
take it.
Oh, right, because it's horizontal strip. Yeah.
Horizontal
Yeah.
strip is
Yeah, I got it.
yeah, the x
Got
of
it.
the right curve minus x of the left curve.
Yeah, I got
When you
it.
take vertical strips, it's y of the top curve, y of the bottom curve.
I know.
Yeah, guys, please be careful here. You have to take the right curve as 3y minus y square.
Yes, sir.
Okay?
Mm-hmm.
Shreya will sleep off now.
No.
And this will be y square minus 5y, correct? Am I right?
Yes, sir.
Correct?
So it will be from 9 by 4 to minus 25 by 4.
No. It will be from y of this, which is 0, to y of this point. Now, for this point, you need to see where these two curves are meeting.
It's 4.
Yeah,
Answer is 4.
so simultaneously compare their x's. So y square minus 5y is 3y minus y square. So Shreya is absolutely correct. It's going to be either y is 0 or y is 4. So this has to go till 4. Can we calculate this quickly? So 3y will be 3y square by 2
By 2.
minus y cube by
Minus
3.
y cube by 3 minus y cube by 3, which is 2y cube by 3.
Okay. Let me combine it before I integrate it, because unnecessary twice integration I have to do. So it will be 8y minus 2y square, correct?
Yeah.
So that will be 4y square minus 2y cube by 3.
Oh.
So that's going to be 64 minus 2/3 of 64. That's 1/3 of 64. That's the answer.
64.
So 64 upon 3 square units. Make sense?
Yeah.
So we need to get confidence in this curve plotting and then seeing which area are we interested in. So one more I will take. In fact, I'll take two more. In fact, yeah. Let's say I want to find out the area bounded by y is equal to sine x and y equal to cos x. Y is equal to sine x and y is equal to cos x. Okay. From x equal to pi by 4 to x is equal to 5 pi by 4.
Oh. Mm.
So plotting will not be a challenge here. Simple. Just
No,
simple
it's
curves.
simple. Yeah. So what will you take as the dx? Is it as a horizontal or vertical?
Okay, you want to say what type of strips?
Yeah, that's what I meant.
Okay. Let's see what works the best. Okay, pi by 4, of course, pi by 4 will be this. Okay, and 5 pi by 4 will be this point. Am I correct?
Yeah.
Mm.
Right? So you
Yeah.
want the area between these two curves in these two zones. So that means I am interested in this area. Correct? Of
Yeah.
course, if I take vertical strips, that would be helpful to me, right?
Yeah, obviously.
Horizontal strips will not work because horizontal strips from here to here I have to divide something else, from here to here I have to divide something else, and down I have to divide something else. Okay. So vertical strips would be the best. So if I take a vertical strip, head of the strip will always be on sin x graph. Yes or no?
Yes.
Tail of the strip or bottom of the
Will
strip will
be
be always be on cos x
on
graph. So
cos x
height
graph.
would always be sin x minus cos x. Thickness is always dx. And integration has to happen from pi by 4 to 5 pi by 4. So what was your question, Shreya?
Nothing. Nothing. I marked it wrong.
Okay. So what is the integration of sin x?
Minus cos.
Minus cos x.
Okay. What's the integration of cos x?
Minus sin x.
Minus sin.
Minus sin. Let's integrate it from 5 pi by 4 to pi by 4. Yeah. The moment you put a 5 pi by 4, you'll automatically get plus 1 by root 2 if I'm not wrong. And again
Yeah.
plus 1 by root 2 for this.
1 by root. Yeah. Plus 1 by
Okay.
root 2.
And minus of minus. So it will become again plus 1 by root 2 plus 1 by root 2.
Yeah.
That means you get 4 by. So answer is 2 root 2.
So cos 5 by 4, sin 5 by 4 is minus 1 by root 2.
Yeah. Cos pi by 4 and
5
sin
by
pi by 4 is 1 by root 2. Yeah. Is that fine?
Yeah.
Okay, try this one. A last question. Then I'll move on to some other concepts. The curve of find the area between the curve whose equation is x cubed minus 2x square minus 3x and the x-axis.
So it'll be a downward opening parabola.
It's not a parabola, it's a cubic graph.
Yeah, it's a cubic equation.
Yeah, it's not a parabola.
If you want, you can actually express it like this.
Yeah.
Okay. Is this factorizable further? I think so.
X into x minus 1.
I think so. Correct?
X plus 1. Yeah.
Yeah. So which clearly signifies that this curve is going to be cutting the x-axis at 3 points.
At minus 1, 3 and 0.
Okay. So since x cube has the leading coefficient as a positive term, it will always come from down.
Yeah.
Or you can always make a wavy curve sign scheme. So minus 1, 0, 3. It will be plus, minus, plus, minus. So minus means it will always come from the below the x-axis. Okay? Is that fine? Cuts. Goes off. So what they want this area.
Wait, so why does it go down before 0? Shouldn't it go down after? Oh, never mind.
So plus, minus. Plus means up.
Yeah.
This is plus side, minus side, again plus side, minus side. Okay? Chalo, quickly tell me what expression should I write to get this area, let's say A1 area. Given area, what expression should I write? Shreya will tell me.
That x cubed minus 2x square minus 3x. Yes.
Shreya?
Yeah, I'm doing integral of x cube minus, no, it'll be the same. X cube minus 2x square minus 3x.
From where to where?
From minus 1 to 0.
Absolutely correct. Aditya will tell me for the other one. A2.
Aditya?
Aditya? Aditya?
Sir, my connection. Yeah, sir, my connection went.
Okay.
Yeah. Can you hear me?
Yeah, I can hear you. Loud and clear.
So I had to move to the other room, right? So the internet's pretty bad.
Okay.
Um,
So I was asking what's the expression for A2 that I should write.
Yeah, that's what I said.
What should I write?
For A2. Just a sec. 0 to 3, same thing.
No?
No, minus.
There's the catch here. Now when you make a strip, the head of the strip is on 0. And the base of the strip is on x cube minus 2x square minus 3x. So it's 0 minus this.
Yeah.
Because if you don't do these, your answer will start coming out to be negative. This ensures that your answer is a positive answer. Getting it, Aditya?
Yeah.
Okay, so basically we need to integrate this term. By the way, that will be x to the power 4 by 4 minus 2x cubed by 3.
So funny. Okay. It is 3x, correct.
Is that fine?
Yeah.
What is the answer going to be? 0 is going to be 0 for sure. Minus 1 is going to be 1/4.
1 by 4 minus 2
2/3
by 3 minus 3 by 2.
So that's going to be negative. This is going to be 3 plus 8, 11. 11 by 12 minus 3 by 2. Minus 3 by 2 is 18 by 12.
Minus 9.
That
Minus 7 by.
It will never be negative for sure, because the way we have taken it is always positive height and positive width.
Yeah.
So by mistake also negative answer will not come.
Yeah.
Okay. What about this? So this is already negative x4 by 4 to x cubed by 3 minus 3x squared by 2. 3 to 0.
0 to
So minus, when you put a 3, you get an 81 by 4.
1.
And this will become 18.
27. 7.
And this will become minus 27 by 2. And 0 will be a 0. Correct? Again, you'll realize you'll never get a negative answer. So, if I'm not wrong, I can write it as 81 by 4 minus 72 by 4 minus 54 by 4. Okay, that's going to be negative 81 minus 126 by 4.
207.
No.
Positive.
35 by 4.
Oh, it's minus.
Sorry, 45 by 4.
Yeah, if you add it, it's.
Cool?
Yep.
So total answer will be what? Total area will be what?
45 by 4 plus.
45 by 4 plus 7 by 12.
Yeah.
7 by 12. Now again for 7 by 12, let me multiply with this 3.
So 142 by 12.
147. 142 by
142 by 12. That is going to be 71 by 6. Let me check the answer. Oh, it's correct. 71 by 6. Chalo, for a change, now I will give you a question where the curve is not given to you in Cartesian form, but it is given to you in a parametric form. So find the area enclosed by a curve whose parametric equation is x equal to 2 cos theta and y is equal to 3 sin theta. So this is a curve whose parametric equation is as follows. And we need to find out the area between the curve. That means it's a closed curve. And it's needless to say that it's actually an ellipse. So they actually want to see what is the area which is enclosed within an ellipse. Okay, so this entire area they want. How do I do this?
So it's just one thing. Right? You just take the strip. Okay. It doesn't matter.
Okay, so what should I write? What expression should I write?
Integral of.
No, you should change it first to an equation, right?
Is it required, first of all? Can I not do it without changing it? Do I have to waste time converting it to a Cartesian form and then do it?
No. If you know it's an ellipse.
But you don't know it's an ellipse.
He said it's an ellipse.
Nobody said, but it's part of the question. Okay.
Yeah, it's a part of the question. The area enclosed by the ellipse.
Okay.
So just integral of 2 cos theta minus. No. So So what interval do you take?
Yeah, that's a question. What is the expression for the area? If I talk about a normal curve, okay, let's say, okay, what's the expression of the area that we actually write?
F of t minus f.
Let's say I give you a question where I just want the area in this part of the figure. Let's say only this part I want.
1/4 of the total area.
Of course, that's why I'm finding it out, because I know it's 1/4. So what will be the answer?
Whatever that coordinate expression.
See, actually, when you make this rectangular strip, the strip has a height of y and has a thickness of x, isn't it? So when you integrate it from this point to this point, the area of the strip is actually given by this expression itself, isn't it?
So 4 times that.
Correct? Yes or no? So in general, when I talk about the area of this part, you take y. So y is nothing but 3 sine theta. Dx is nothing but, what will be dx? Dx will be nothing but -2 sine theta d theta.
It's -6 sine square theta.
Right?
Okay.
Now, the problem comes, what is the theta value here that we are looking for? Now, theta value here will be from 0 to pi by 2. Yes or no? Now you would say, sir, how did you know it's 0 to pi by 2? See, this point coordinate is known to us. This point coordinate will be 2, 0, right? And that only comes when I put theta as pi by 2. Theta as 0. And this coordinate is 0, 3. That only comes when I put theta as pi by 2.
Pi by 2.
So if I do this, my answer should be there in front of me. That means I want to find out the area of 12 times, in fact 24 times.
-20.
Yeah. -24 integral of 0 to pi by 2 sine square theta d theta. Okay. Now, how do I find this out? Very simple.
Sine cube theta.
Sine 3 theta by 3.
This sine square theta, I can write it as 1 minus cos 2 theta by 2.
So why?
Because
I cannot integrate sine square, right? I don't know the formula for that.
-12.
Clear? Okay. So this will give me -12, 0 to pi by 2. Okay, let me just write the result directly. Remember, here we have to take a mod then. This will become plus sine 2, not plus minus. Correct?
yes, sir.
So -12 pi by 2, and when you put, the moment you put a pi by 2, this will become a 0. So answer will be mod of this answer. So area will be mod of -12 pi by 2. That's going to be 6 pi. Now, can you tell me why I have to take mod in this case? The reason I have to take mod in this case is because I had to actually integrate from a higher value to a lower value. A lower value of x to a higher value of x.
Yeah.
Correct.
Yeah.
Now this problem came because I had to integrate from pi by 2 to 0, right? See, I have to go in this direction for my dx to be positive, right?
Yeah.
So when I started from 0, I started from this direction and I went reverse way. I went this direction actually.
So
It's the same thing as integrating from pi by
right. So yeah, so I did a mistake which I should not have done initially, because I always keep on telling that if you make the right decisions on your height and breadth, you don't have to take a mod. So this should have been 0. This should have been pi by 2.
Pi by 2.
Okay. But anyways, we understood why this sign came out to be negative. Is that fine?
We just scroll down.
Yeah. Should I scroll down?
Yeah. Yeah, go.
Got it? Let's try one more question of this type.
Yes, sir.
Find the area enclosed by one arc of the cycloid. Find the area enclosed by one arc of the cycloid with parametric equation x equal to theta minus sine theta and y is equal to 1 minus cos theta.
What's a cycloid? Yeah. So what's a cycloid?
You have done your electromagnetism, right?
I'm not.
No, sir.
No.
No.
Achha, now you have not done it, right? Oh, I forgot. Cycloid is like this. This is a cycloid.
Oh, yeah.
Okay. It's basically a open part of a helical
a
path.
mod of a sin x graph.
Kind of. It is not exactly sine graph, but it's a kind of that. Okay. What is the question asking? Find the area enclosed by one arc of the cycloid. One arc means I just need this area. Any one of them we find out. This area I need. So first of all, again the same methodology you would apply y dx, right?
Yeah.
So y dx.
1 minute.
Correct? If I'm not wrong, the dx here would be 1 minus cos theta.
Cos theta dx. Yeah.
Okay. Correct. Now,
D theta.
I'm worried about integration. From where to where should I integrate?
From
1 to 0.
What will be the theta corresponding to this point?
pi. It should be from 0 to pi. Pi to 0.
What do you think?
So not pi. Right?
See, these are those points. This is a point where both are 0, right?
Exactly.
So tell me an angle for both this and this both are 0.
And theta is 0.
Theta is 0. So it has to be 0.
0 to pi.
Correct. Now this is a point where
Again, both are 0.
y is 0, not both are 0. Y is 0 only.
Exactly.
So cos theta has to be 1 there. So it has to be
Exactly.
2 pi.
2 pi.
Correct. Yeah, understood now.
Got it.
Get it? So now this becomes 1 minus cos theta the whole square d theta. This you can integrate by expanding it.
1 minus 2 cos theta plus cos square theta
Okay.
x.
Yeah. We can
Theta.
still simplify this as 1 plus cos 2 theta by 2.
So
Remember,
why do
huh?
oh cos square theta? Okay.
Yeah, remember we cannot integrate powers of trigonometric ratios. Instead, we have to convert it to higher angles of trigonometric ratios. Correct? So half plus 1 will be 3 by 2, if I'm not mistaken, minus 2 cos theta plus half cos 2 theta. Yeah, what should I write? 3 by 2
3 by
theta?
2 x theta minus 2 cosine theta plus half. Oh, right. Okay.
Aditya, are you with me?
Yeah, wait, sir. Why did it become 3 by 2 over there?
Because half plus 1.
This half and this one. So it's 3 by 2 into 2 pi minus 2 sine 2 pi would be 0 if I am not wrong.
Yes.
And this will also be 0.
0.
Okay. And 0 everything will be 0. So your
Yeah.
answer will be 3 pi.
3 pi.
Is that fine?
Yes, sir.
Yes, sir.
Okay. In some cases, you may be given not even Cartesian, not even
Polar.
parametric, they may be giving you polar form, right? And then they would ask you the area, between the two polar forms. Now, just an expression for polar forms. Let's look into that. It's very simple. So whenever a curve is given to you, r is equal to f of theta. Okay. The area in the polar form is basically given by half r square d theta. Correct. From a value theta 1 to theta 2.
So now your voice is echoing. So is mine. Disturbing.
Oh, now my voice is echoing.
No,
Let's
it's
stop
fine
it.
now.
Let's stop. This is the area. Okay. Where
Yeah.
r you have to replace with your f of theta. So it will become half f of theta whole square d theta. Let me show you an example. Find the area enclosed by the cardioid. Find the area. Aditya, you're there?
Yeah, yes.
Find the area enclosed by the cardioid.
So what is card?
Cardioid is that heart-shaped thing, right? Which we did in the start.
Okay, yeah. That's what I want to cover with Aditya because he has missed out the initial classes.
But I thought you sent him the record.
Yeah, he is busy with the concert.
What concert?
Yes.
Some concert he went to. This is a cardioid. I'll show you on GeoGebra also.
Sir, I didn't go for concert. Sir, I was performing at.
Oh, really?
Yeah, that's why I didn't.
You had to go because you're performing.
Yeah.
What was that, by the way? Piano.
No.
Guitar.
Guitar. So I learned guitar.
Oh, that's good. Yeah, this is a cardioid. Did Divyansh come to see it?
Yeah, but then he missed it. Like he came late.
I told him we are going to get the
Oh.
pics. The man is saying, no, sir, I'm going to the doctor.
No, sir, his grandmother is also sick, so he went there. Yes.
Oh, okay.
That's why he was saying.
Hope nothing is serious.
I know it's like, you know.
Okay, you see this figure? Then that resembles a heart actually. That's why it's called a cardoid. Okay. Now, what I have to use is this expression, plain and simple. Half r square. R square means square of this term. So it's 4 1 plus cos theta whole square. Okay. D theta. Now the challenge is from where to where I have to integrate it. Again, remember the angle that you make is from, this is your theta. So let's say this is theta is 0 here. Then theta will be 90 degree over here. The moment you reach here, it will become theta equal to 180 degree. Correct? So, yeah. So do you see, all of you see here that this figure is symmetrical about the x-axis, correct? So if I just integrate it from 0 to pi and double it up, my job should be done.
Yeah.
Correct. So let's figure out what's the area. So it's 4. 1 plus cos theta, the whole square is 1 plus 2 cos theta plus cos square theta. 0 to pi.
Wait, so why do you multiply with 2 on the outside again?
Yeah, because as I showed you, this figure is symmetrical about the x-axis. So basically, this line is your theta equal to 0 line. Okay. This line will become theta equal to 180 degree line. This is 180 degree line. Correct. So if I just integrate it from 0 to 180 degree, I will at least cover this part of the area. Half the cardoid. Yeah. Okay. So again, here I will use my conversion of higher degree to a higher angle. So it's 1 plus 2 cos theta, and this will become 1 plus cos 2 theta by 2. So that would become 0 to pi of 3 by 2 plus 2 cos theta plus cos 2 theta by 2. Okay. So now let's integrate it. So this will become 3 by 2 theta plus 2 sin theta. So when you put a pi, it will become 3 by 2 pi. Rest everything will give you 0.
Yeah.
So again, this answer is 6 pi, coincidentally. 6 pi square units. Understood how it works?
Yeah.
So I think by mistake I had given this question in objective test to you, right?
Yeah.
Okay. So we'll take few more on this.
So you corrected that, by the way, just asking.
No. I was too busy today. I'll correct it tomorrow. Okay, so let's take a question based on parametric form.
Parametric or polar?
Oh, sorry, polar form. Yeah. This would require maybe the use of a calculator. Find the area enclosed by the 4 leafed rows r equal to cos 2 theta. Okay. Find the area enclosed by the 4 leafed rows r equal to cos 2 theta. Options are 0.785, 1.571, 2.071, 3.142, and 6.283. By the way, just to show you on the GeoGebra how it looks. R equal to cos of 2 theta. See this? Rose? Okay. Now here itself, can you suggest me from where to where will you integrate this?
Um,
Do you see that one
can
of
you
the
do
part
two
is
of them? One is vertical, one is horizontal.
yeah, total area is 8 times the area of half the petal.
Yeah.
1, 2, 3, 4, 5, 6, 7, 8.
Yeah.
Correct. Now I start from 0 and this petal ends at pi by 2. Correct.
Yeah.
Correct. So can I say it's half r square d theta term, and I'll integrate it from 0 to pi by
0
2.
to pi by 2, 8
8
multiplied by
times.
8. Yeah.
Is that clear, Aditya? Okay, so let's go back. So it would be half r square d theta 0 to pi by 2 8 times. I don't think so you'll need a calculator to evaluate it, but of course you'll need a calculator to calculate the values. So 4 times 0 to pi by 2. Cos square 2 theta, I can write it as 1 plus cos.
Plus cos 2 plus 4 theta pi.
Is that fine?
Yeah.
So this will be theta plus sine. So your answer will be pi by 2. So 1.571, if I'm not wrong.
Pi by 2. Okay. Yeah.
Next question. I'm not going to the volume today because I think you need a bit of practice on the area itself. The volume I'll take up tomorrow. Volume and arc length.
Okay.
The area bounded by the small loop. The area bounded by the small loop of the limicon r equal to 1 minus 2 sine theta is given by which of the following options? Option A, you don't have to evaluate it, you just have to find out which expression will give you the answer. Half of 1 minus 2 sine theta whole square. Option B is 7 pi by 6 to 3 pi by 2, 1 minus 2 sine theta the whole square. Option C would be pi by 6.
So we can use a calculator.
No, you don't have to evaluate it. You just have to figure out which expression will end up giving you the required area.
But for that, we need to know the limits, right? And for that, we need to know the graph now.
For graph, you need to use the calculator. That is.
Yeah, that's what I'm saying.
Yeah. This is still not over. This is again 5 pi by 6 to pi. And this E is yeah. Do you want to see a limicon?
It's like part of it.
Oh, yeah.
So you have to find this small loop.
What? Mm,
Wait,
so can you go back to the?
why just that? Is the limicon only that part, or
No, it's given in the question.
So
Find
can you
the
go?
find the area of the small loop.
Can you go back to the question?
so it'll be so
Yeah. Again, you want to see the curve? This is the curve.
Mm. So I think the answer is C.
C for cat.
Uh huh.
Why do you think so?
Just okay. Wait. um. No, so I think it should be B. Huh?
D. B for ball.
B. B for ball.
Okay. Aditya, what do you think?
I said B in the start.
Okay. First thing first. What does the small loop signify here? Why this loop has actually come about? This loop has come out because in this loop your R is negative quantity. Getting the point?
Mm-hmm.
So first thing that you need to ask yourself that in what zone will your R be negative?
Mm. What do?
When this term will be negative?
Right? 2 sine theta is greater than 1.
No,
Yeah, of course
sine
you'll say
theta
1
is
minus sine theta equal to 0 will be the critical value. That means sine theta is half will be your critical value. So at pi by 6 will be critical value, right?
Yeah.
Correct.
Yeah.
So you would realize that this would be negative all the way from theta equal to pi by 6 to which value?
Theta by 2.
Two.
Again, when it reaches a half value, which is 5 pi by 6. Yes or no?
Yeah.
Correct.
Yeah.
So ideally, my answer should be half of 1 minus 2 sine theta square d theta from pi by 6 to 5 pi by 6.
But there's no. Yeah.
Correct. But there's no option
Just-
like this. But you can see that this graph would start becoming, look at this curve. At 0, it is having this value.
Mm-hmm.
The moment you reach pi by 6, it will become a 0.
0. Yeah.
So this point, let me clear this up. This point that you see will be corresponding to your theta equal to pi by 6. Correct?
Mm-hmm.
Yes or no?
Yes, sir.
And this entire loop, again this point when it comes, again theta becomes 5 pi by 6. Right? What will be the midway between this? Theta will be equal to half of, yeah, it's, you can say, average of pi by 6 to 5 pi by 6, which if I'm not wrong is pi by 2, right? Correct?
Mm-hmm.
So basically what I'm doing is, if I evaluate this area and double it up, my answer will be there.
So I didn't get, how did you get pi by 2?
6 pi by 6. 6 pi by 12.
If you take pi by 2, it becomes negative 1.
Yeah,
That's
but
why
how
this,
did you know that it's average value?
yeah, I'll tell you why. This is equal to minus 1.
Yeah.
Do you see R is at minus 1 here? Do you see minus 1?
Yeah.
Let me clear it up. Do you see a
Yes,
minus
sir.
1?
Yeah.
So when will R become a minus 1? When sine theta is 1. So when theta is pi by 2.
Oh, you did that. Okay, yeah.
Correct.
Yeah.
So can I say that in light of this, my answer will be doubled up of pi by 6 to pi by 2,
Mm-hmm.
which actually matches with option C.
Hmm.
Got it?
Yes, sir.
Okay.
Mm-hmm.
Okay, let's take one more on parametric. The area enclosed by the hypocycloid.
So what's a height?
Hypocycloid, I'll show you hypocycloid. You have seen, do you play cards?
Yeah.
Speed.
Oh, diamond.
Yeah, the diamond is actually a hypocycloid. Yeah. Okay. So find the area enclosed by the hypocycloid whose parametric equation is x equal to cos cube t and y is equal to sine cube t. Options are, again, they don't want you to calculate the answer. They have given the expression for it because they just want to test your understanding, not waste your time evaluating it, whether you are able to apply the right concepts to get to the expression which has to be integrated to get the area. Let me tell you, these concepts would be of lot of weightage in your calculus exams. By the way,
No, it'll be either A, D, or E.
that's too many options. Should not be difficult.
It,
Ultimately, you have to find 1 and 4 times it, right?
Yes.
So remember y dx.
I think it should be D.
Okay, let's check. What do you say, Aditya?
I think it's E.
Dx. What will be dx? Dx will be 3 cos
3
square
cos
t
square
into
t
negative
into
sine
Negative
t
sign.
dt. Correct? Now here, what will be a theta? Theta here will be pi by 2, here will be 0. So can I say drop off this negative sign and do it from 0 to pi by 2?
Yeah.
Oh, I'm sorry, you don't drop the sign. You have to do it negative from pi by 2 to 0, correct?
Yeah.
Okay, yeah.
And this is the same as
And this will be 4 times. And yes, I told you when you flip the limits, negative sign will go off. So it will be 12 times 0 to pi by 2 sine to the power 4t cos square t. Option D is correct. Let me check the answer. 44D. Yeah. It will be in the handout which I'm going to send it to you.
So can you send a recording of this video?
Same. Yes, sir.
Okay, I'll send it.
Because I need to view this one more time too.
Okay, okay. I'll send it to you. Okay. So I'm going to stop here because after this I have to start with volume and arc lengths and all, which I wanted to start tomorrow. By the way, please tell me what time is suitable for both of you. Will 8 to 10
We
be
can stick to 8 to 10. It's not a problem.
morning?
Mornings are not possible. Because, see, I have 8 to 10, then after that I have centum at 1.
We can do afternoon, like
I have
No,
1 to 4.
1 to 4 is a class. Okay. Okay, fine. So we'll meet in the evening only, 8 p.m. to
6 o'clock. Okay.
10 p.m. Okay. It's only for tomorrow that we'll have a problem because I think Monday onwards we can have it sometimes early evening. Okay. Okay. Fine then.
Yes, sir.
Okay, let's call it a day. Thank you so much.
So, one question.
Yeah.
In the paper you gave me first, you had basically given me the last question of the paper. So, do you have the paper with you?
First question, functions question.
Yeah, that's relations and function. I mean, yeah, that
Uh,
test.
I have the paper in soft copy and my phone has just switched off.
Okay.
What is the
So
question?
there
Tell
was
me.
this the last question of that paper. Okay, yeah, wait.
I sent you the solution also, no?
Yeah, but yeah, I actually have a doubt in that.
Okay.
So basically, I think you had given me a graph and the asymptotes were given to me. And you said find the values of A and B in the equation which is given, y equal to e raised to x plus something. Okay, and in that you had so I draw. So can you draw it? I'll tell it to you what it is, and then the graph was cutting the y-axis at -1.
It's like sketching the graph of a criminal from the eyes of a witness. Let me on the phone because I've just put it for charge. Just give me 1 minute.
Yeah.
So we have further application, differential equation, sequence and series. We are done with the course then. But we have to do a lot. Yeah, sequence and series.
Okay, I got the question. You still? Should I tell you?
Yeah. No, I'm opening
Why?
the question.
Okay.
Last question, right?
Sir, it's okay.
Yeah, got it.
No. I just realized. No, it's okay. So we can.
Graph of y is equal to a e to the power x plus b by e to the power x plus 1, right?
Yeah, so I don't have a doubt now.
Oh, okay.
It like vanished because I just realized what I was. Okay, never mind. It's fine.
Okay.
Okay.
Sure, never mind. Let's meet tomorrow, 8 p.m. Okay.
Yeah, yes, sir.
Okay, then over and out.
Yes, sir. Bye bye.
Bye bye.